بسم الله الرحمن الرحيم رب زدني علما.
Okay, now in this section, we'll try to get into some of the wireless basics, now basic wireless theory we can say. So where I'm going to cover the basic theory initially in the first video, and then we'll try to understand the different, what is frequency and the different ranges of the frequency. And then we'll try to understand the IEEE 802 dot standards and also 802.11 standards, which are designated for the wireless LAN. So let's get started here. So if you just go with the basics in the OSI model, like OSI, so there is something called a physical layer. Now this physical layer is going to define the actual transmission of your data over the transmission media. Now depending upon what type of transmission media we are using, so if I'm using some kind of copper cables, the information, whatever the data, is converted in the form of electric signals if you are using the copper media. And again, if you're using the fiber media, the information will be converted into the light signals if you're using fiber optic cables. But again, here we'll be discussing about the wireless media. Now in the wireless media, the information goes through the air. Now air is a medium and the information is sent in the form of radio frequency signals or the radio frequency waves. So we'll talk about a little bit more in the later on sections, like what is frequency and exactly what it defines. Now here we need to understand the basic wireless theory first, like how the wireless is going to work. So if you take an example, if I'm using a wide network, now when you're connecting the wide network, so let's say I'm connecting a copper cable, so your information goes in the form of electrical signals, and these electrical signals are generally continuous and they are conductive. So the signals are propagated from one end to another end automatically. So which means you don't need to really do anything. So they are more conductive devices. So they will be carrying the signals from one point to another point. Of course, there will be a distance limit depending upon what type of cable or the standards you are using. But now the question is, if I'm using the wireless connection, now there is no exact physical connectivity between the two devices here. So let's take an example. This is my access point and then this is my PC, and we say that they are connected, but air is the whatever the air, the free space is actually your medium, which is going to carry the signals. And of course, these signals, we call them as frequency signals. We'll talk about that. So in order to understand how exactly the signals are carried between the two devices which are connected wireless, now we need to understand a couple of examples here. Like if you take one of the example here, let's say there is a person, sender, is trying to send the information to the receiver on the other side. You can say sender, receiver, or A and B. Now the A is trying to send information to B, and they are connected via a long rope. So let's say they are connected via a long rope, which is going to represent your free space. So this is, you can correlate that with a free space. Now the question is, now the A person is trying to send the information. Let's say he decides to send the information. So he's going to lift the rope, indicating the receiver that I'm trying to send the information. Now when he tried to do that, probably it will, now you can see, now probably what happens is when you're lifting the rope, you're actually expecting the other end also, the receiver also should be informed that, okay, I'm going to send information, now you are ready to receive or not. But normally what happens is the actual, at the back end, the rope will fall back after some distance, we can say, and the receiver actually doesn't see any difference. So there's no difference at all. There's no difference at all. There's no change, which means the receiver actually doesn't know anything that there is a change in the state of that particular rope, or the sender is trying to send some information. So this is what we call as failed attempt to pass on the message down to the rope. Now if you take the second example, now in case, now if you want to send information, let's say the same example, again I'm using the rope, the same, but this time I'm using a different strategy where the sender actually start sender actually begins to wave the rope up and down. So this is a kind of wave. So wave the rope up and down. So which is going to generate a regular motion or a steady motion of the rope. And based on this motion of the rope, now the receiver actually see the difference. Now you'll see that there is a continuous wave pattern appears, and that is actually continuous along the rope, as you can see in the figure here. Now this wave is like one up and one down. So it's like kind of one cycle, which is going to complete one cycle of one up and one down cycle. And this wave actually travels from sender to receiver. So you can compare the same thing with your wireless. So when you're trying to send the wireless, now this rope is like a airspace. So that is same like an airspace, and your wireless signals will use the same principle while sending the information from sender to receiver. That's how actually it goes. Now, if you try to compare this example with your basic wireless, how it works. Now, in the basic wireless, what happens is the device will be having a specific antenna. Like, let's say this is my access point or any other wireless device. Now, probably this is actually having an antenna, and it is going to propagate the fields, and technically we call them as electromagnetic fields. That's what it's a combination of electric and the magnetic fields. So we call them as electromagnetic waves or electromagnetic fields. So these are actually propagated outside the antenna. So it's like, propagated outside the antenna. And again, it depends on the type of the antenna and the type of the device, how long this information or how long this wave is actually propagated. Okay, so these electromagnetic waves, they travel with each other, and it always like right angle. Right angle means around 90 degrees right angle generally. And these signals generally they keep changing and altering and cycling up and down. So whatever the signals, it will go in this format. Of course, towards the outside from the antenna from that particular wireless device. This actually travels outward. Now, one thing you need to understand here is, again, this particular electromagnetic waves, they don't go in a straight line. So they travel something like this. So electromagnetic waves, generally they travel by expanding in all directions away from the antenna. Okay, so they don't go like a straight line. So you can compare this with an example of this diagram. Generally the diagram, think about dropping a kind of pebble into a pond when the particular surface is still. Now the pebble set is going to set the water surface in a kind of cycle motion here. So you can compare the same example, how the electromagnetics are expanded outwards towards in all directions. And the same thing happens here. So typically you have an antenna, access point have an antenna, and the same thing, the electromagnetic waves or the signals are propagated outwards from the antenna. And all the devices which are specifically within this particular coverage area, they will be able to be connected to that particular centralized device here. Now again, how long these signals will go, it totally depends upon the type of the device and the type of the antenna or the standards what you are using. So totally it depends upon multiple factors.